Good evening, everybody. It's from Jayashree from SNS College of Technology. I'm going to take this differential amplifiers under the unit of operational amplifiers. Okay, let us see what do you mean by differential amplifiers. Okay, what is differential amplifiers? If V1, V2 are the two input voltage applied to the op-amp circuit, right? If V1 is connected to the inverting amplifier through the resistance R1 and V2 is connected to non-inverting amplifier, that is plus through R2, and this both input are connected together to form this operational amplifier. If RF is connected as the feedback from output to the input, okay. Here this is what this output signals. Here V1 and V2 are the two input voltage which is given at the op-amp circuits. We get this differential output. It will be like this. One is in phase with the input and another output is out of phase with the output. That is what this differential amplifier. Okay. So differential amplifiers commonly referred to as difference amplifiers are the fundamental building blocks in operational amplifier circuits. They amplify the voltage difference between the two input signals while rejecting any common mode signal that is present on both the inputs. Okay, let us see what is the advantages of differential amplifiers. So first one is what? Noise rejection. By amplifying only the difference between the input signals, differential amplifier rejects noise that is common to both the inputs. This makes them particularly useful in environment where noise is present. Next one, improved linearity. Differential amplifier often exhibit improved linearity compared to the single-ended amplifier, especially when used in feedback configurations. Okay, next one is what? Increased dynamic range. So differential amplifiers can provide a large dynamic range compared to the single-ended amplifiers, which can be beneficial in application where the wide range of input signal need to be accurately amplified. Next one is what? Common mode rejection ratio. Differential amplifiers typically have their parameters called common mode rejection ratio, which quantifies the ability to reject the common mode signals, and high CMR values indicate the better rejection of common mode signals. Okay, this is what the advantages of differential amplifiers. Number one is what? Noise rejection. Number two is what? Improved linearity. Number three is what? Increased dynamic range. Number four is what? Common mode rejection ratio. Next one is what? Applications. So applications of the differential amplifiers include instrumentation amplifiers. The instrumentation amplifiers are specialist differential amplifier designed for precise amplification of small differential signals, commonly used in measurement and instrumentation systems. Next one is what? Data transmission. In communication system, especially in differential signal schemes like RS-485, then differential pass in Ethernet connection, differential amplifiers helps in transmitting data with high noise immunity. Next one is what? Biomedical sensors. Differential amplifiers are often used in biomedical sensors and measurement equipment to amplify small differential signals from electrodes, such as those used in electrocardiography, that is ECG, and electroencephalography, EEG. Okay, so the applications what? Instrumentation amplifiers, data transmission, and biomedical sensors. Next one is what? Audio amplifiers. So audio application, differential amplifiers can be used to process balanced audio signals, offering noise rejection and improved signal fidelity. Next one is what? Control systems. So differential amplifiers are used in control system to amplify the difference between the desired and actual signals, facilitating feedback control. At last, signal conditioning. So differential amplifier used for signal conditioning in various sensor interfacing application and providing amplification and noise rejection. Okay, so let us take the summary of the today class. So what is meant by differential amplifiers? We seen differential amplifier, we are giving the two difference between the input signal to the operation amplifier, produces the output. One is what in phase with the input and another output is what out of phase with the input, both together to form this output. So differential amplifier is commonly defined as difference amplifier is the fundamental building blocks in operational circuits. They amplify the voltage difference between the two signals while rejecting any other common mode that is present on both the inputs. So advantages are noise rejection, improved linearity, increased dynamic range, at last common mode rejection ratio, and applications are instrumentation amplifiers, data transmission, biomedical sensors, audio amplifiers, control system and signal conditioning. Okay, so these are the application advantages. Let us see the next topic in the next class. Thank you.